Hello, my name is Paul ANGRAND. I've been a postdoc researcher for the ANGRAND project. I worked with Frédéric Moutoureau on a kinematic reconstruction of Iberias in the late Paleozoic, and I will here present a summary of my research work. During this postdoc, I have been working on two studies. The first one is a kinematic reconstruction of the West Tethys North Atlantic region in the late Paleozoic, early Mesozoic. This allowed to investigate the late Permian and late Cretaceous of time. The study was published in Solid Earth in 2020. The second study is an extended kinematic model from the late Paleozoic to present day at the same region, with an emphasis on the orogenic phase. We ask questions such as the distribution of the deformation and the role of intraplate deformational zone within continent. This study will be part of the BSGF Orogen special issue. Our first study shows that two tectonic corridors have accommodated the Iberia-Europe movement from the late Permian to early Cretaceous. The late Permian and late Triassic period is key to better understand the rifting evolution of this region. Therefore, we may wonder why this period has been neglected. The lack of geological constraint must be explained by the thick late Triassic apodictic sequence that efficiently decouples the thin tectonics from crucial deformation. Our second study shows that Iberia is a continental puzzle that cannot be considered as a unique plate, and it is important to consider intraplate deformation in kinematic reconstructions. During the inversion, the deformation first localizes at the external boundary before to propagate inward. Finally, rift depot centers have been constantly reactivated in extension and compression since the late Permian Triassic. To sum up, we showed in our first studies that the late Permian Triassic geodynamics played a major role in the evolution of the West European kinematics. Then, we proposed that the Iberia-Europe plate boundary was not only localized within the Pyrenean Rift Basin, but extends to the intra-Iberian basin as well. In addition, strong mechanical coupling must have been active throughout the Cenozoic to efficiently transfer the deformation from Africa to Europe. And finally, this is our conclusion, we recommend to integrate intracontinental deformation zone into regional kinematics and geodynamic studies.